everyone. I am Naitik Nakrani, Solution Architect at Einfochips. So today I'll be talking about a really interesting topic, practical guide to scale multi-robot fleets using OpenRMF. So most of you might have probably seen autonomous robots, maybe a turtle bot or a vacuum robot or any industrial robot. Uh, so moving from one robot to many is not about just an adding a quantity, but it introduces a lot of complex coordination problems. So this session will be speaking on how one can solve this kind of fleet level challenges. So here is the outline. I'll be talking about first what are the fleet level challenges are. Then we'll give you a brief about what OpenRMF is. Then the architecture that implements the OpenRMF and connects your robot with the OpenRMF. Then there are key steps you need to follow in order to implement this fleet management. And we'll end up with certain key takeaways along with one demonstration video. So working with one robot, life is very easy. But when you move from one robot to let's say 5 or let's say 50, you will really hit bottlenecks. So we did a small experiment at our facility. What we did is we ran two AMRs continuously in a loop from point A to B to C to D in opposite manner, and they were running independently with their own SLAM and navigation stack. So what happened when they came across? You'll see that they are stuck, right? And at some point of time, it gives an anxiety. And luckily, it didn't collide. But you can see that there are this is the kind of a challenge that we are talking about when you are moving from one robot to multi robots. So what essentially is required in order to create a smoother, smarter, and a safer navigation stack? So clearly, you can see there is a lack of communication in between robots. This is about peer-to-peer communication, and I think we need tools like Zenoh, which comes in handy tool in order to enable a peer-to-peer communication. Congestion. So these robots are stuck; they don't know where to go, and orchestration where nobody are there to guide one robot that which goes fast, which goes left, which goes right. Optimization is again required when you need an shortest path in the shortest time. So when the robots are moving independently in a single space which is narrow, then that might create a trouble. And the most important is interoperability. On this basis, the OpenRMF has been introduced. So open interoperability is the challenge where you need to integrate multiple vendors with multiple SDKs and multiple libraries to be bring into single software layer. So OpenRMF comes in as a solution. It acts as a command and control system, a scheduler, and an orchestration layer. OpenRMF stands for Open Source Robotics Middleware Framework. So consider it as your traffic police system, which takes care of your traffic congestion, which assigns different tasks to different AMRs or your fleet robots, and then it acts as a fleet adapter, which brings multiple vendors robot into a single system. And it has a lot of tools and libraries which is running on top of your ROS2 SLAM and navigation layer. So it comes with its own traffic management library or node, you can say, because it's a ROS2 based implementation. There is a traffic editor where you can define your traffic within your space. Then it has a different task dispatcher, and you can add different infrastructure as well. Like for example, you can add your the IT-enabled doors and lifts within your OpenRMF as well. So this is a picture of an OpenRMF under the hood. So it has a layers. You have a physical robots at the bottom, which are running independently with their own SLAM and navigation system. Then what you need is an kind of a bridges and adapters, which actually connects your physical robots data into your RMF core. RMF core is a backbone of your OpenRMF system, which is running on your system because this is a centralized communication navigation system. So your OpenRMF core is running on a server, and then at the end you have an RMF web, which is kind of a web-based dashboard where you can where an operator can see what is happening in your robot. So this slide shows you the key steps that you need to follow in order to implement OpenRMF based implementation. So first is a Zenoh bridge that is must for your communication. So it enables communication between your physical robots and your OpenRMF core. Then you might need an creation of map which OpenRMF understands, and you need to create an navigational routes, or there is a term called nav graph within that OpenRMF. Then you might need to align your SLAM map along with your OpenRMF map. And then you need to enable your fleet adapter, which actually connects your physical robots with OpenRMF. And then once this many steps are done, then you can assign different tasks to your robots. So first step is enabling a Zenoh communication. So I think Mr. Angelo and Mr. Vivek has given a very nice talk about what is a Zenoh and what are the advantages. So simply what you need is you need to have a Zenoh bridge installed in your physical robots as well as your server. On physical robots, you might need to run Zenoh as in a client while your core system or your host machine on which your OpenRMF is running has to be set as in Zenoh router. So simply once, and then these are the certain config parameters that you might need to set, which takes care of what type of topics, ROS2 topics you need to connect between your robots and the OpenRMF. Here you can control different topics that needs to be published in between, and also you can take care of their frequencies as well. So mostly what OpenRMF needs is a transform, and what it how it controls your robot is through your navigation stack action, which is a navigate to goal action. Okay, so once your communication is established, then what you need is and create a graph. So those who have worked in the SLAM might recognize the first picture. That's an occupancy grid map that is generated through an SLAM algorithm. Typically, you need to fetch this kind of a open occupancy grid map into your traffic editor, and you need to create an map which OpenRMF understands. So this is similar to how you create a map in your gazebo environment. What you need to do is you need to add walls, vertex, and you need to add a measurement which actually aligns your SLAM map with your OpenRMF map. Then you need to add certain routes, which is called as a navigation graph. This navigation graph act as an your traffic lanes on which your AMR can go. Okay, so fleet adapter, as I said, it actually translates physical robots data into your OpenRMF. So within the OpenRMF system, for any kind of a ROS2 based robot, OpenRMF has one package called free fleet adapter. That's an example of how you can connect any ROS2 based system into your OpenRMF. So free fleet adapter translates your data into OpenRMF system. And this is the example of configuration that you can add. So mostly it needs data like what kind of fleet or what kind of robots we are adding into, because typically in the earlier implementation of OpenRMF without the Zenoh introduction, there was a problem of how you can distinguish different kinds of robots. So you might need to use a namespaces. Those who have worked in the different robots might know about the namespaces. And then there is a lot of challenges happens due to DDS limitations. So because of Zenoh introduced recently and OpenRMF fleet adapter implementation is pretty easy for multi robots. Next step is to align map which is generated by SLAM and the map that you have created in your traffic editor system. So what essentially is required is a reference coordinates. So on left side you can see you have to choose any 4 different vertices in X and Y coordinates. And on the right hand side you can see it's an RV's map. So it's an actual SLAM system which is running on your system, and you might need to get the exact coordinates from the RVs, and then you need to enter in your configuration file for your fleet adapter. This is very much essential. This is the way that how your OpenRMF localize your AMRs which are running on your physical space. So once your communication is established, your map is generated, and your fleet adapter is running, then your system is set, and you can see the status of your robots in a GUI dashboard. Let's call it as a RMF web. This is a picture of how it looks like. You can see the live status of both robot on your OpenRMF map. And the way that you have created your navigation graphs is also can be seen, and then you can manage your task through this OpenRMF web dashboard. You can assign different tasks, you can schedule a different task of your navigation goals, and then it also provides you the live information about what is happening in your robots. So this is a small demonstration of how we implemented the OpenRMF for our 2 AMRs. This is just an example. You can add many more robots into your fleet using OpenRMF. So what we did is we just created in one common path in order to move both AMRs. So, and we gave both AMR a continuous goals to move from one end to the opposite end. So you can see that one robot, once your path is clear, then and then your second robot starts moving. So that's how the OpenRMF traffic management comes into the play. It takes care of your path, and then it controls or it manages which AMR has to go first, and then which has to wait for certain time. So this is called a negotiation between the tasks that OpenRMF does. Okay, all right. So we are moving to the end. So key insights from what we learned of this implementation. So like many other fleet management system, OpenRMF is also evolving technology. So definitely there are scope for the improvements. What we have seen is as of now, when you add multiple robots, so for the cartographer kind of a SLAM algorithm, which somebody might know that it requires your robot to be placed at exactly the same location or the starting location in order to start its localization algorithm. So the initial push, which is additional information that we provide in order to localize the AMR, that kind of facility is not present in your current OpenRMF implementation. So you might need to do a little bit of tweaking in order to implement different kind of SLAM algorithm along with your OpenRMF. Then what we have seen, like as traffic, I mean, when you are seeing on the road that at every crossroads there is a challenge in the traffic. Similarly, in OpenRMF, when your routes are crossed, when they are intersected, then there are certain cases where your AMRs moving from one up in a cross direction typically collides because they don't, there is some kind of a latency issue. Because of that, there are problems in controlling the motion at the intersections, and this is a very big problem in any kind of a fleet management system. And this works based for the AGV kind of a spatiotemporal planning, because it has a straight path where you can control your AMRs and your results are deterministic. And then we kind of face problems of synchronization, because many robots are generating the time TFs, which is your pose information, and it creates a problem because of synchronization. Your OpenRMF or traffic manager fails sometimes in order to handle the traffic. And then we kind of have seen latency on the web. So these are the certain points where the improvements are required. So what is a big takeaway? Scaling is definitely a hard problem, but your OpenRMF makes it manageable. So it comes up with a lot of different tool chains, which can make your one robot solution or navigation stack into fully managed fleet orchestration. Okay, that's it from my side. If you want to know more about what work we do, then please follow us on LinkedIn, and then you can contact us at this email ID. And if you have any questions for related to this topic particularly, then we can have a chat. Thank you.